Hello and welcome to today's class. Let's look at yet the final type of variation called the partial variation. Put down, when a variation is expressed as a sum of two or more parts is called partial variation. So when it comes to partial variation, I'll be expressing a sum of two or more parts, right? So when it comes to expressing the sum of two or more parts, right, is said to be a partial variation. So for example, so let's say if y varies directly as x. So let's say if y varies directly as x, right, and partially varies inversely as p, and we said this y again is what partially varies inversely, that is inversely as what? P squared. Look at the word. I said if y varies directly as x, as we know, and partially, that same y again is partially varies inversely. So that word partially varies, that word partially varies is that I'll be combining it together. When I give definition, I said is expressed as the sum of two or more parts. Part 1, part 2, combine the two together, right? So I'm saying that if y varies directly as x and partially varies inversely as p squared, it is written as, the partial variation is written as, observe here, I'll have y, this symbol, y is still y, this symbol, right, remains, or perhaps, let's start with this, I'll combine this together. This is proportionality sign, this is x, Abby. Alright, okay, I have x, right, so plus, this is plus, or if you want to, let's do this way, from here, I can see this y and y. So this y is now equal to, if I take up partial side, I have equal to, then kx. Now, instead of using k as my constant in, when it comes to partial variation, becomes a, right? So this is, change this partial sign to equal to and a constant. In this case, I don't use k, I use a as my constant. So plus, here now, y is still your y. This symbol signifies equal to, now it remains constant. My constant becomes what? B, right? Into what? 1 over p squared. Observe what I just said earlier. Now observe this. Y is this y. Change the symbol to equal to and a constant. In this case here, my constant is not k, but a. My constant is a here, and I have x here, no problem. But from the word I gave you, I said that, and partially varies inversely as what? As p squared. So I'll combine. So at this point now, this y still remains as y here. This symbol signifies equal to and a k. But in this case, I'll not use k, I'll use constant. But the constant here what? Will be b instead. Because what? B into what? This. So in essence, I'll have that y is equal to ax plus 1 times b is b over p squared. This is how you express partial variation. So I will add those two stuff together in the sense that for my first constant here it will be a, my second constant here will be b. So where a and b, all right, notice this, notice it, where a and b are called are constants. So also note that, note this please, the value of a and b can be found separately by solving simultaneous equation. So note that to get a and b, right, when it comes to partial variation, you're going to pass through what we refer to as simultaneous equation. So here's the thing. Let me try to explain this again, right? So let's say I have, because that's the main foundation for partial variation. Let's say I have p very directly as x and very partially as what, as, let's say that y very partially as the inverse of let's say q squared, for instance. So this word is read p very directly as x and partially varies inversely as p squared. So that it's written. So write this one in partial variation form. This becomes p, is that same p now? I'll use that same p, please. It's p. I'll use that same p. So pp. So for me now, I have that p is equal to, I'll put k. Instead of k, my constant becomes ax. So plus, here now, this p and p are the same. So this p is already outside here. This symbol represents equal to a k. So since I put equal to here, I don't start putting k here. My second constant becomes b into what? 1 over q squared. I have this. From here, p is equal to what? Ax plus b over q squared. This is like your expression for partial variation. Alright, having said this, let's do some example to further explain the concept of partial variation. Hold on guys a little bit. Let me tell you what you need to know. Actually, I'm running a membership program, right, which can help you a lot. So to join my channel membership, it's quite easy task, right? As you can see the icon I'm showing you here, that icon is my membership opportunities, which you can access monthly. So I'll drop the link to the membership in the description of this video, right? So just click there, click on the membership link, so you purchase the one you want. So I have for JAM and YA classes, and also I have for 100 level students. So whichever one suits you, click there and subscribe. If it, perhaps click there and purchase the one of your choice. Anyone you purchase, there are several advantage videos that I will not allow people to see. So it's for only those who have joined the channel that will have access to those even advanced problems. And also, I do help students from different countries to solve their assignments. So if you're in UK or abroad or Canada or anywhere you are in the world and you want me to help you do your assignments, you can simply check me. You can simply visit me on my WhatsApp number, or also share this video. I'll drop a link to a website there. In the website, you can register with us and you let us know which assignment you want us to help you to do. Do well to join the channel. Thank you. You can proceed with your learning now. Example 1, please. U, letter U, capital U. U varies directly as x and partially inversely as the square root of m when U is 56.75, x is 8, and m is equal to 16. And when U equal to 86.6, s is equal to 12, m equal to 25. Question A says, find the equation connecting U, S, and M. Question B says, also find the value of M when U is equal to 105.5 and S equal to 15. All right, that's all, please. So that's all. So let's start number 1, please. Example 1, please. Example 1 on this. How do you solve this problem when it comes to partial variation, please? The task is quite easy, right? Go back to the question. It says what in the question? It says that U varies directly as x. No problem. I have U varies directly as what? As x. All right. And partially inversely. And what they? And partially inversely. And what? And this same U again is what? Partially inversely. right, as what? As square root of m. That is square root of m. All right. So square root of m, where you observe this case. So when it comes to partial variation, you'll be given u, s, and m. Like what you are given. This question now contain only u, s, and m. You'll be given the value of u, x, and m two times. They'll give you u, s, and m for the first expression. They give you another u, s, and m again, right? So you have to put the values two times. What do I mean? Look up from here now. Let me just simplify from here. Using this concept, we know this concept here. Let me get the partial fraction form of this one. U and u is the same thing, so I have u, right, varies directly as what? As x. But in this case here, change the symbol to equal to and a constant. Constant here is a first, then x, plus next constant becomes b into what? 1 over root m. So I have this. From here, u is equal to ax plus b over root m. This is my partial fraction. So this is my partial variation, right? Expression here. So this will become my relationship between u, s, and m. But mind you, I'm given the value of u as being equal to 56.75, and I'm also given x as 8, also given m as 16. This is the first one I'm given. I'm also given u again as 86.6. I'm given x as 12. I'm given m as what? 25. So I have this. So it means that with this equation I've gotten, with this relationship I've gotten, I'll try to put u, x, and m here as the first equation, u, x, and m was second equation there. So for the first one, so for me, I'll have that u equal to ax plus b root m. From here, this is u. What's u for the first one? U is 6.75 equal to a is a constant. What's x? X is 8. I have 8, so becomes 8a per se plus b. What's b? B is a constant. B is a constant over root. What's your m? M is 16. I have 16 here. From here, I'll have 56.75 is equal to what? 8a plus b over 4. Of course, root 16 is 4. All right, next part here, it's easy, right? If I want to eliminate this fraction here, I multiply through by 4. So let me just say multiply through by 4. That is, I'll have 4 into 56.75 equal to 4 into 8a plus 4 into b over 4. Observe. Here it's in, multiply 56.75 by 4. I'll have about 227 equal to, multiply 8 by 4. I'll have 32a plus, this cancel this, I'll have b left. Call this one here, call this man your simultaneous equation 1. Call this one equation 1. I have this because we said to find a and b, you're going to pass through simultaneous equation. That's why this thing is given twice, right? So this is my first one. My second one here is this. So also recall, go back to equation. U is equal to ax plus b over root m again, and put all these values here inside here to have a second equation. From here, I will have that u, what's u? That 86.6 is equal to A is a constant. What's your x here? X in this case is 12. So if I put 12 here, it should be about 12a plus b is a constant root. What's your m here? M is 25. So m here is what? 25. From here, I will have 86.6 equal to 12a plus b over what? Over 5. 25 is 5. To eliminate this fraction, I multiply through by 5. So multiply through by 5. So I'll have 5 into 86.6 equal to 12a plus, so multiply through by 5. So 5 into 12a plus 5 into what? B over 5. So I have this. Multiply 5 by 86.6. All I get there, I'll have 433 is equal to 12 by 5. I'll have 60a plus 5 times 5. I'll have b. Call this one here your equation 2. So I'll now solve equation 1 and 2 simultaneously to get the constants a and b. So a and b is constant, so we always get the constant first, a and b. So at this point now, solve equation 1 and 2 using certain equation. Alright, my equation 1 I have that 227 equal to 32a plus b as my equation 1. Equation 2, I have that 433 60a plus b is my what? Equation 2. It's easy at saying, let's say from equation 1, let's solve this one using substitution method, right? So from equation 1, I have that from equation 1, look up equation 1, I want to make b stand alone. So I have that b is equal to, take this one here, that becomes 227 minus what? 32a. If I make b subject from equation 1, this one should move here. So I shall have 227 minus 32a, right? As the expression here. So it means that they call this equation 3, call this equation 3, right? Call this equation 3, right? So from here now I'll proceed with the solvings. I'll proceed from here. Alright, so I've gotten b here. So I'll put this expression into equation 2. So put b as being equal to what? 227 minus what? 32a into equation 2. Equation 2, I have 433 equal to 60a plus b. So instead I see b, put what? This expression. So I have 433 equal to 60a plus what's b? That's 227 minus 32a. Please ensure it's in a bracket this way. From here I'll have 433 equal to what there? 60a plus times 227, that becomes plus 227, plus minus is minus. I'll have 32a. I have it here. I can easily take this one here. I'll have 433 minus what? 227 equal to what? 60a minus 32a. Subtract 443 from 227. I'll have 206, right? Equal to 60a minus 32a. That will give about 28a. Let's get a from here. Let's get a from here. Let's get a from here. All right, for me, let's get A, please. Divide by 28. So 206 over 28 equal to 28A over what? 28. That's the concept. So this should cancel this. I'll have that A is equal to what? 206 over 28. I'll have about 7. If I approximate, I'll have 7. So I'm saying that A now is equal to what? 7. I've gotten A. Let's get B. How do you get B? So put A equal to 7 into what? Equation 3. That says what? From here, please. From here. B equal to 227 minus 32A. So I have no A as 7. Put 7 here. So B is equal to 227 minus 32 into 7. Right? A is 7. So put 7 here. So B is equal to 227 minus 32 times 7. That gives 224. So therefore B now is equal to 3. So I've gotten my two constants. A and B are known now, right? So I've gotten my two constants. So what's the question now saying? The question now says, what's question A say? Question A says what? Find the equation connecting them. I think so. The equation connecting U, S, and let's get the equation connecting. So question A says that the equation connecting U, S, and M. So from here, the equation connecting U, S, and M is given by what? No, we said that earlier. This is the equation connecting them. I gave you earlier before now that U is equal to AX plus B over root M. I can leave it this way if I want to, but I've already know my constants. I have no A and I have no B. Just put them there. So U now is equal to, what's your A? A is 7. I have 7x plus what's B? B is 3. 3 over root M. So this becomes my equation connecting U, S, and M. Question B says we should find M. B says find M, right, when U is equal to 105.5 and X is equal to what there? 15. So it's easy. Go back to find something, or to find something this way. You have to record back your connection equation, right? So record this back. So recall that we said U is equal to what? 7x plus 3 over root M. So I have to find what? M, right? So find M. So let's get M. And then after M, we are off. Let's get M. Let's get M from here. All right, to get M, it's easy, right? It's easy. Here's the logic here. I have to get M. Before then, take this one here. I'll have U minus 7x equal to what? 3 over root M. From here, right? I have this here. Next up, if I want to put the values there, what's U? U is 105.5. So 105.5 minus 7 into what's X there? 15 equal to what? 3 over root M. I have this. For me, I will have 105.5 minus 7 multiplied by 15. 7 times 15. 7 times 15. That should give 105, right? 105. 7 times 15, 105. So equal to what? 3 over root m. Alright, proceed from here. This minus this will give 0.5 equal to what? 3 over root m. By the way, I'm looking for m. My task is what? I'll multiply. This times root m is what? Root 0.5 root m. 0.5 root m equal to what? 1 times 3 is 3. I want to get m. So divide by what? 0.5 by what? 0.5. This should cancel this. I'll have root m equal to what? 3 over 0.5. But by the way, I'm not asked to find root m. I'm asked to find just ordinary m. So I'll what? Square both sides. So square both sides to eliminate this root. So I'll have root m all squared equal to what? 3 over 0.5 all squared. This should cancel this now. So what's m? M is equal to 3 divided by 0.5. I'll have 6 all squared, right? From there, therefore, m is equal to 6 squared is what? 36. So this is my value of m, right? As you can see, this is how to solve problems when it comes to partial variation. So in the question there, right, you try to express, you try to get your form of partial. If they give you a question, try to get the partial fraction form, how it look like, right? As we did initially, we got this form first. Next task is that we'll be given, like in this question here, I'm having just u, s, and m. They'll give the value 2 times. They'll give you u, s, and m for the first one, us and m for the second one. So you now use your connecting equation of the partial variation. So you not do it with this initially, like we got equation 1, equation 2, and then from there you solve simultaneously, then you have your m's and your constants. So this is how you solve problems on partial variation, right? It's as easy as this. So if you do not solve simultaneous equation, it will fail you, right? So you have to learn that, not to do simultaneous equation, so to help you in understanding of partial variation. If you don't understand this video, watch it again, right? Watch it again and then watch it again, watch again, then you to stick. So that's how you learn. All right. If you found this class helpful, do it to share to your friends and classmates. Like this video, leave a comment, and also if you're interested in assisting towards the enlightenment of all this information that we've given, you can do it to assist us or donate at least whatever you have to our progress of this content creating. You can reach me out to my WhatsApp number and then we'll discuss. All right, thanks for watching and welcome to Excellent Link Academy. See you in the next class.